So I think that the graph for this particular one is going to be a little bit hard to see, so I might bring up my advanced grapher again. So, I mean, the way I have it now, it looks like the whole thing is shaded, which is not technically the case. So let me bring up my advanced grapher so you can get a better picture. Okay, so you can see what I'm saying here is that I've got 92% in this center right here. And that means I have a certain percentage in each of the tails, which is kind of hard to see on the other graph because I've mushed it so much, but there's empty whiteness in here, okay? So what I want to know is, what are the two z-scores? What's this number here and this number here on the right-hand side that would cut it off and make it so that the middle is worth 92%? Good question. Okay, so let's think about this. What's the area in the left tail? Okay. Actually, let me back it up. What's the area in the center? And then what's the area in the left tail? Let's start with that much. All right, so the area into the center is 0.92, right? So what's the area in the left tail? Well, for starters, it's got to be 1 minus, parentheses, 1 minus that number. Then you have to divide it by 2 because each tail gets its own. So if 92% is in the middle, that means 4% is over here on the left, and by the same token, it's also equal to that amount. Okay. Notice what do these three numbers add up to? 92 plus 4 makes 100. 100%, right? The whole thing. Okay, so now we need to find the left hand. They're called critical values, if you want to know what they're called. Or the left hand z-score, let me put it that way. Z-score. That would be equal to norm dot inv, or norm inv. You don't need the dot if you're in an older version. Sorry about that. That's one of the things they changed. That's the probability. The mean is 0. The standard deviation is 1. There we go. So the one on the left is negative 1.75. Now we all know what the right hand one's going to be, right? Hopefully, since the curve's symmetric, right? But I want to find it for you. I want to show you a couple things. So this is, let me be a little more clear up here. This was the area to the left of the left hand z. Does that make sense? So there's a left hand z on the left and there's a right hand z on the right, and we found the area to the left of the left hand z. Now I know that the area to the right of the right hand z is the same, but let me back it up and let me do the area to the left of the right hand z. Did you catch what I mean? I mean all of this area that's shaded plus this area over in the tail, all of that up until this guy right here. How much is that? Well, that would be 1 minus this. I mean, if the area over in the right-hand tail, let me bring it back up. If this little white area over here is 4%, 0.04, then doesn't everything else have to be 96? Yes, it does. Exactly. So why did I do that? Well, remember norm S inverse, or norm inverse, or norm dot inverse, which is what I'm going to use, that one. They require left tail probabilities. It doesn't do you any good to know that the area over to the right is 0.04. Useless, because it doesn't get used for the function in Excel. What you need is the left hand area, and the left hand area is 0.96. So I'm going to use that, 0.96, comma 0, comma 1. And that's positive 1.75, just like we thought it would be. Now I know you're thinking, oh, I'll never have to do that. Contraire, because we're not always working with a mean and standard deviation of 1. This whole, they're the same number, but one's positive, one's negative thing only works if it's the standard normal distribution, which this one was. All right, let's see if I can squeeze C in here. C is the picture already drawn. When you see a subscript like that, that means it's the area in the right. So what's the area in the left? The area in the left is 0.85, right? So the z-score is going to be equal to norm inverse 0.85, comma 0, comma 1. There you go. So this particular value is 1.036. Just be sure when you're using Excel for that one, you find the complement, right? 1 minus 0.85. Make sure you do that. Or excuse me, 0.15.